Welcome everyone. Today we will try to understand level order traversal of a tree. So basically, level order traversal. Okay, so first let us understand what do you mean by traversal. So a traversal is nothing but a way to traverse all the nodes in a tree. A way to traverse all the nodes in a tree. But the order of the way, the order in which we are visiting the nodes, is decided by some condition. Okay, so whenever you say whenever you say level order traversal, the it means that the traversal is based on the level of the node. So what I mean by this is that first we will try to traverse the nodes which are at level 0, then we will traverse or visit the nodes which are at level 1, and then we will go to the nodes which are at level 2. Okay, so in this example 2, so like in this example 2 we have, okay, uh, nodes at level 0. Nodes at level 0 are, okay, we have only one node, so that is 10, that is the root node. Nodes at level 1 are 20 and 30. Nodes at level 2 are 40 and 60. So what will be our level order traversal? Our level order traversal will be 10, then 20, then 30, then 40, then 60. Okay, so okay, so 10 is at level 0, 20 and 30 are at level 1, 40 and 60 are at level 2. You can clearly see from the graph. I'm talking about this graph. Okay, don't see the upper graph, see the example 2. Okay, I'm talking about this graph. Okay, so this is the level order traversal. Note that the level order traversal can also be like 10, 30, 20, 60 and 40. Okay, so these two are at the same level, right? 40 and 60 are at level 2. Then why are you traversing 40 first and then 60? So by convention, just by convention, like this is also one other possible level order traversal. So by convention, what we do is that by convention, we always we always start from the left. Okay, so we always start from the left. So let's say here you have, let's come to the example. Okay, here you have 10, then you have 20 and 30 at level 1. So what you do is that you first traverse from the left. So when you come from the left, first 20 comes and then 30. It's just a convention. We can also do the other way around as well. Okay, so first 30 and then first 30 and then 20 also is also fine. You can also take that as a level order traversal only, that's also correct. But just generally by convention, everyone writes this way. They'll first start traversing from the left. Okay, so both are correct, so both are level order traversals only, but this one is more conventional. Like this is what actually people implement, and or this is what actually they call as level order traversal. But this is also correct because node 10 is at level 0, 30 is at level 1, 20 is at level 1, this is at level 2, and 40 is also at level 2. Okay, so you just need to maintain this order of level. Okay, so first we have to start with 0 level, then 1, then 2. Okay, so now let's come to the code implementation part of this level order traversal. Okay, so the first thing that I'll talk about the prerequisites. You need to know STL, basic stuff like stacks and queues, and that's all is the prerequisite for this basic HTL of stacks and queues. That's all. So how will you create a stack, or how will you create a queue, and how will you push nodes inside a queue? So that's the basic part we should know. So okay, so let's define the structure of a node. So our structure of a node is like we have an int data and struct node star left and struct node star right. Okay, so this is like the basic structure of the node for a tree. So basic structure is this. So we will take this as a structure, and then we will try to write code according to this structure. So let's say we want to print the level order traversal. So what we will do is like, void print, and let's say a root node of a tree is given to us. So struct node star root. Okay, so the first thing we need to check whether the root is null or not. If root equal to null, then we need to just return it. Okay, we don't have the tree only. So when we have the tree, the first step we need to do is like, this is same for every level order traversal. Okay, so like it's a blueprint. Like try to write level order traversal like this only. So I'm like the what I'm implementing is same for every level order traversal. Okay, the steps will really be same, like exactly same. Okay, so the first step what I'll do is like, step one, I will create a node. I will create a queue. Okay, I will create a queue using STL. Okay, using STL. Okay, so okay, queue. Okay, so what is the data type this queue contains? It contains node star. Okay, it contains all the pointers of struct node type. Okay, it contains all the pointers of struct node type. Okay, so let's call this queue. Okay, okay. Now the second step. Okay, step two, push the node, push the root node. Okay, push the root node. Okay, so queue dot push root. Okay, now we have to start the loop. Okay, so while let's leave about the termination condition of this loop. So let's come to the while loop. Okay, so let's come to the while loop. So what we are going to do is that, okay, okay, so first we will define a temporary node. Okay, we will define a temporary node. Note that this is same for every program which I'm going to write further. Okay, I'll do so many problems on trees. In the same way only I'll write level order traversal. There will be no change. There will be no change. These steps will always be the same. Okay, there will not be any change in these steps. Okay, so okay, we will define a temporary node. So node star temp equal to queue dot friend. To access the queue dot friend, this is the friend node. Like this is the friend of the I mean like the node present in the front of the queue. Now after accessing the friend, we should pop it from the queue. Okay, we should pop it from the queue. So okay, so we will try to understand how the queue is now. So in the first step, our queue contains only 10. So we need to push the root. So in the first step, our queue contains only 10. Okay, so now we have removed 10. We will remove this 10 and push 20 and 30. Okay, so we will remove this 10 and push 20 and 30. So let's try to understand this, how we'll do that. Okay, so so first we'll remove 10. So we have removed the 10, so we have to push 20 and 30. Okay, now after this we will remove the friend, that is 20. So and after removing 20, what we need to push? The children of 20. So what are the children of 20? The children of 20 are 40 and 60. Okay, so when you remove 20, so you will have 30, 40 and 60. Okay, so here you have removed 10. So remove 10. Here you have removed 40, remove 20, sorry, remove 20. Okay, remove 10, push 20 and 30. Okay, remove 10, push 20 and 30. Okay, remove 10, push 20 and 30. Okay, now what is the front of the queue? In the front we have 20 now, right? So remove 20. We always remove the front of the, we always remove the road which is at the front. Remove 20 and push its children. What are the children of 20? You have 40 and 60. So push 40, 60. Okay, so now okay, so now in the front we have 30. Okay, so 30, you have to remove it since it's in the front. Okay, we have to remove it from the queue, and we have to push its children. So 30 doesn't have any children, so like we need not push any nodes. Okay, so now the queue becomes 40 and 60. Okay, okay, so now what we need to do is that we need to just remove 40 because 40 doesn't have any children to push. So same goes with 60 as well. So we have 60. Okay, we need to remove 60. Remove 60. Okay, so and now the queue becomes empty. Now at last the queue becomes empty, and this is the point where we need to stop the while loop. This is the point where we need to stop the while loop. Okay, so this is what we are doing. So first I'll explain it again. So first we have to push the root node. Okay, first we have to push the root node. Okay, so what is the root node here? 10 is the root node here, so we have to push 10. Okay, we have to push 10. Okay, so now the queue becomes now the queue has 10 and it will go into the while loop. Okay, this is all under, it will go into the while loop, this will go into the while loop. Okay, so in the while loop, you have q10, I mean in the queue you have node 10. So we have to remove node 10 since it is at the beginning of the queue, and you have to push its children. What are its children? You have 20 as well as 30. Okay, so we have to push 20 and 30. Okay, now the queue becomes 20 and 30 because 20 and 30 are pushed, and also 10 is removed here. Okay, 10 is removed here, so you have 20 and 30. Now what is there in the front of the queue? You have 20. So what are the children of 20? You have 40 and 60 are the children of 20. So you have to remove 20 and push its children. Its children are 40 and 60. Now you have 30, 40, 60 in the queue. Okay, so in the front you have 30, right? So what are the children of 30? You don't have any children of 30, so you have to just remove 30. Okay, now let's come to the queue. Our queue has 40 and 60. Now 40 doesn't have any children, so remove 40. 60 also doesn't have any children, so remove 60. And now finally the queue becomes empty. So now we have to terminate in this condition. Okay, we have to stop the loop when the queue becomes empty. Okay, so let's try to code this. So okay, so we are accessing q dot friend, and we have to pop the friend element as well. So q dot pop. Okay, so step 1, create a queue. Step 2, push the root. And okay, so while loop termination is while q not equal to q dot empty is true. Okay, when it is empty, then the loop should exist. So okay, so q dot pop. Okay, every level order traversal will be same. Again and again I'm saying you, every level order traversal will be same. Okay, so first we need to create the queue, we need to push the root, and then go into the while loop. Okay, first we need to create the queue, we have to push the root, and then go into the while loop. In the while loop we have to access the front of the queue, we have to access the front of the node in the front of the queue, access it, and then remove it using q dot pop. Okay, q dot pop. Okay, now our temp node as the front node address, right? Front node address. Okay, so okay, so let's say we are having address of 10. Okay, so in 10 you have the address of 20 and 30 as well, since 20 is the left child and 30 is the right child. So you need to push in order. What is in order? I already told you that by convention we start exploring the left, we start exploring from the left. So first we will check whether if temp is having any left child or not. If temp arrow left is not equal to null, then we will push into the queue. Okay, okay, now if temp arrow right is not equal to null, then we will push this as well. Okay, okay, note here very like I mean, like observe this very carefully, why we are writing this if condition first and this if condition second, and what will happen if we interchange these both. Okay, if we interchange these both, okay, if we interchange these both, then first 10 will go, then 30 will be pushed, and then 20 will be pushed. Okay, so the level order comes from the right and not from the left. This is just by convention. We first explore the left and then go to the right. Okay, so if it is reversed, like if these two if conditions are reversed, like first you are checking whether right is there or not. If right is there, then push that right node into the queue. Then first 10 will go, like this step will remain the same since you are pushing the root. Okay, now if you check whether the root has right child or not at first and then push the right, then first we will explore 10, then 30, then 20. We will start exploring from the right. Okay, now here what code we are writing is like, we are exploring from the left in a level. Okay, we are not exploring from the right, we are exploring from the left in a level. Okay, so in a particular level we start exploring from the left. Okay, now you have pushed the children of the current node as well. So this is our current node. Okay, this is our current node. Okay, we have pushed the children of the current node as well. So we have to push with checking. Okay, we have to check whether the left child exists or not. Okay, first we have to push the left child and then we have to push the right child. Okay, so now what we need to do is like, since we are just printing it, we will print the data in our current node. Okay, and L. Okay, and okay, so that's all is the level order traversal. Okay, we will try to do the question as well. Okay, so to get some more clarity about this. Okay, so let's come to the question now. Okay, so here is the question, so I'll close this. Okay, so let's come to the question now. Okay, so here you have a level order traversal. We have given the root node. Okay, so let's change it to root. Okay, so we have to return a vector having level order traversal of a tree. Okay, okay, so the first step is, as I told, if root okay, let's create a vector now. Let's create an empty vector now. So answer, let's call this answer. So if root equal to null means there is no tree only, then we have to return answer. Okay, so let's say we have a root. So first thing what I have told, you have to create a queue of node star. Okay, of, since it contains pointers of the nodes, node star queue. And the second step is we have to push the root. Okay, we are pushing the root. And the third step is we have to start the while loop. Okay, we have started the while loop and it terminates whether it's till queue is empty. So these steps will remain the same. Okay, these will remain the same for every level order traversal. Okay, then we have to create a temporary node. Temporary node. Okay, so to access the queue dot friend. Okay, q dot friend. Now q dot friend is accepted, we have to pop this. Okay, remember that this is very important, because if you don't pop, this will go into infinite loop. Okay, this will go into infinite loop. This step is very 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 important. Okay, so these five steps will remain the same. Okay, these five steps will remain the same. Okay, so now what we need to do is that we need to check whether our current node has any left child or not. If the current node is having any left child. Okay, so this means that current node is having left child. Okay, when it enters this if condition, so we need to push that left child as well. So q dot push temp left. Okay, that's all. Now we will come to the right. If it is having right child, we need to push that as well. So this says that our current node has right child as well. Okay, so q dot push temp star right. Okay, so q.push temp star right. Okay, so now pushing is completed. So what we need to do, we need to, okay, we need to also push our data answer dot pushback temp arrow data. Okay, so since we are storing in the answer, we have to push back our current data as well. We can also push here also, like. Okay, so first we will so before pushing the children, we will push our current node data into the answer vector. So answer dot pushback temp star temp arrow data. So this is like, for the answer. pushing the data of our current node. Okay, and then we have to ask whether the our current node has left child. If it has, push it. Whether the current node has right child. If it has the right child, then we need to show temp star right not equal to null. Okay, okay, okay. So then we need to push it. And okay, so when the okay when this while loop is completed, our answer vector will have the level order traversal. So we need to just return the answer, since it's asking us to return the vector. Okay, so let's compile it. I don't know, like it may show up some errors as well. Okay, so let's try to submit the solution and see. Yeah, so okay, so everything is fine. So let's recap the steps now. So the first step is, like, you have to create a queue of node star. Okay, create a queue of node star, push the root, create a push the root, go into the while loop, start accessing the first element and pop it, start accessing the first element, or start accessing the front element, that would be more precise. Start accessing the front element. Okay, push its children into the queue and then pop this out. Okay, so this is what we have done. Okay, so basically this is what level order traversal means. We need to traverse the tree level by level. So these steps are like blueprint. Okay, so these steps will remain the same. So first we need to create a queue, we need to push the root, when we have to go into the while loop, we have to access the front element, we have to pop it. Okay, so these and push the children. Okay, so these will remain same in any level order traversal. Okay, these will remain same in any level order traversal. I request everyone to practice this at least 5 to 10 times before going into the next questions, because in next questions, like, I won't be explaining in detail. I'll try to follow this blueprint, so you need to understand this well, so before going further, so it's easy to understand as well. So thank you for this video.